In this video, I am going to show you how to trim paired end widths using the tool Trimmomatic. So for this tutorial, the only requirement is to have Trimmomatic installed on your PC. Yeah. Instructions for installing Trimmomatic can be found in the description box. Alright, so if you want to read more about Trimmomatic, then visit this page. This is the manual. I have left the link to this page also in the description box. So just check it and then read more about it. Alright, now let's take a look at what we are going to do today. So let's open the ebook. I have it here. And by the way, the down link for this ebook is also available. So check the description box, you'll find the down link. All right. So we are going to trim paired end widths, and this is the syntax we will use. For the syntax, I have grouped them into two: basic options and then trimming options. Now with the basic options, after calling Trimmomatic, we'll call this mode, that's a P. That means we will specify P. That's paired end widths. So because we are dealing with paired end widths, we have to use the P. And then we will also indicate the number of threads. And then we will indicate read 1 and then read 2. So read 1 contains the forward reads, read 2 contains the reverse reads. And then we also specify the output files. Now with Trimmomatic, if you are dealing with paired end widths, 4 files will be generated: 2 for forward, 2 for reverse. Let's start with the first. So we have output forward paired and then output forward unpaired. So the output forward paired are forward reads that have made pairs in the reverse reads. Output forward unpaired are forward reads that do not have made pairs in the reverse reads. We also have output reverse paired. The same. These are reverse reads that have made pairs in the forward reads. And then the output reverse unpaired, those are reverse reads that do not have made pairs in the forward reads. And then we also need to specify the trimming options, which are here. All right, so a description of each of these can be found in the ebook. I took the description from the Bioinformatics manual, which I showed earlier, this one here. So you can find all the options here, the descriptions are there. All right, so you can check that out. All right. So after that, we will proceed to download an example data, and then we are going to trim. That's what we are going to do. Now, this tutorial is a reproduction of this online guidance tutorial here. So this tutorial, I've covered some aspects of it, the variant calling aspect. I've covered it in another tutorial, and then I showed the trimming activity, but I thought I'll separate the trimming in another video so that I go into details with it. So I will leave the link to this page also in the description box. So when you are here, just scroll down to the retrimming and filtering, and you have the instruction there. So I am basically reproducing the instructions here. That's what I'm doing. So in case you want to read more, you want to find out why I'm using those values, I got them from this tutorial here. That's what you need to know. All right, so let's get started. So we will start by downloading the example data. Let's just go back to the gallery tutorial page here. So when we are here, let's just start here. So when you are here, just come to get data, and then you have the session given to you. Now the data, you can use any, but for this tutorial, let's just use this one here, this very first one here. That's what we are going to use. Of course, if you have the ebook and then the bash script, you can always modify the script and then use a different data. That's fine. So I'll need these links. Okay, so I'll download them one by one. So I'll copy this first, and then I'll move to the terminal. You can also download by clicking if you're using your browser, but I will do everything on the terminal. So let's just go there. Let's open our terminal first. All right, so on the terminal, I'll first create a directory in the trimming, and then I'll cd into it because I'm treating this as a project. All right, now I'm going to download the example data. Now I'm downloading the fastq file. So the first one, that's read one, I'll use wget and I'll paste the download link there. So this will download the read one for me. So let's wait for everything to get done for us. All right, read one has been downloaded. So let's do an ls and we are going to find the file there. Now let's download read two. So I'll go for the download link. So again, let me go to data. Yeah, I'll download this one here. There's the read two. That's the reverse. So read one is forward, read two is reverse. So let's download read two. So again, we call wget, we supply it with a link, and this will download the read two for us. All right, read two has also been downloaded. So let's take a look at it. Let's do an ls and we are going to find it's there. All right, so we have both files downloaded. Now let's also download the adapter. So if you take a look at the data, let's just go to the Galaxy tutorial page. So we are dealing with Illumina reads. All right, so we will need to also specify the Illumina adapter. So with the adapter, let's just scroll down to the trimming section here. With the adapter, let's just check. We are supposed to use the TrueSig3. This is the Illumina adapter. All right. So the adapter can be found here in the Galaxy tutorial page here. So the adapter can be found here in the Trimmomatic GitHub page here. So I will leave the link to this page also in the description box. So in this tutorial, we are going to use TrueSig3-P, this one here. But if you are going to reproduce this tutorial using your data, then you need to just make sure you check with your sequencing facility to get the correct adapters or adapter file. So just make sure to do that. But for this tutorial, we are going to use TrueSig3p.fa. So we are going to download. So just visit this GitHub page, and then when you are here, click on this one here, and then you'll be sent to this page. So when you are here, you can click on raw, and then right click and then save pages, or you can just on the raw button here, just right click it and then copy the link. That's what I'll do to download. So I'll just copy the link and I'll move to the terminal. I'll also leave the download link itself in the description box so that if you don't want to come to this page, you use that to download. So let's download the adapter. So I will say wget and I just paste the link there. So let's download this adapter also. It's a small file, so the download is going to be quick. So we have it downloaded. Let's click the screen and check. So I'll do an ls and I'll find the files there. All right, now let's organize our files. So I'll create a directory and move the fastq file there. So I'll say make the raw reads, and I'll say mv star.fastq.gz, and I'll move them to the raw reads. So if I do an ls, I'll see my raw read directory, ls into it, and I'll see my fastq files. So it's advisable to place your fastq files in a separate directory. So basically, it makes your life easy when you organize the files. So it can help you to also automate your scripts and pipelines, and then to help you to avoid unnecessary conflicts. All right, so let's proceed. So we have all the files that we need. So we need to also start the trimming. So again, the instructions for installing Trimmomatic can be found in the description. So the Trimmomatic installation, you can install using an conda. You can download the jar file. All right. So let's just check. For the sake of beginners, I think I will just quickly show one of the instructions here, or let me just say one of the methods for installation. So I will just quickly download the binaries. So on the Trimmomatic page here. Again, the link to this page is in the description box. So on this page, just come to the right side and then click on releases. This side here. So click on releases, and then you have access to this. So we will download the banner with the jar file, which is this one here. So what I'll do is to right click and then copy the link. And then I'll move to the terminal. And then I'll download it. So I'll say wget and then I'll paste the link there. So this will download the Trimmomatic binaries for me. I'll do an ls and I'll see the file here. All right, so let's just check. Let's do an ls and you'll find it here. So after downloading, I'll just unzip it. And then if I do an ls, I'm going to find this directory here. Okay, this has the jar file. Let's ls into it. We are going to find this file there. It also has the adapters, by the way. So you can basically use the adapters here, or you can download and then use it. All right. So that's how we set up Trimmomatic. So if you use this approach, then you need to make sure you have Java already installed on your system. Okay, so it's important because this one requires Java to run. So the quickest way to test if you have Java installed is to just say Java version. Yeah, so I have Java installed. So if I do Java version, I'll get this output. All right, so if you don't see this, you may see this message, maybe command not found, or maybe Java not found, or something of that sort. So if you do that, you need to make sure you have Java installed. And again, I have tutorials for installing Java, so you can also check the description box. You'll find the links to those tutorials. All right. You can also install using Anaconda or Conda. So if you have conda installed, then you can just say conda create -n, maybe Trimmomatic. You say Trimmomatic. So this will create an environment called Trimmomatic and then install Trimmomatic in it. So this one is the name of the tool that you install. And after that, you can activate the environment. I have several tutorials on how to install bioinformatics tools, which conda and then mamba. So just check the description, or you find everything that you need there. All right, but for this tutorial, you will stick with the Java file here. Okay, so now we are ready to start the exercise. So let's continue. All right, so we can start. So let's do an ls to check our files again. Everything is ready. All right, so we can continue. All right, so what we are going to do next is to create a bash script and then run it. So the bash script will contain the commands that we will use. So let's open a script. I'll use nano, but you can use any text editor. So I'll say nano trimreads.sh and then I'll have it open. I'll add my shebang line and then I will start. So that's what we are going to do. First, we are going to do this. We will say make the trim reads. So this directory, we will create it and then we use the store the output files. I repeat, this directory, we will use it to store the output files. We will create the directory first. We will create this output directory, trim_reads, and then we will use it to store the output files that will be generated. All right, so let's proceed. Now let's do this. Let's define the read1, read2. So read1 is equals to, now I have them here. Let's do an ls into raw reads to get the names. So this is read1. All right, so I'll just do a copy and then paste here. And then read2, I'll also do a copy and paste here. All right, so we have them done. Okay, now there's something else we need to also do. I'll even go over again. I think it's better that way. There's something we need to do first. I think I omitted it and it's important. So I'll start. So I'll define read1 first. So I'll say read1 equals. Now, when I come here, okay, the ls into raw reads, I have it here. So even though we are going to specify the files, this is read1, this is read2, we also need to indicate the directory where we can find them. Some of these things are important. So read1 will be equal to raw reads slash, and then I'll indicate the forward, that is the read1. And then for read2 to be raw reads slash, and then I'll bring the read2. Then we are done. We have specified them. Now let's also look at the output file. So the output files, I made mention that 4 files will be generated. So let's define them. So I'll start with this one. That is output forward paired equals, and I'll say trim reads slash, and I'll define it. So the output forward paired, these are forward reads that have made pairs in the reverse reads. Okay, so I'll have to give it a name. I'll use this base name here. So I'll paste it, and then I'll add this. I'll say dot trimmed dot paired underscore r1 dot fastq dot gz, and then I'll define the output. Let's do it well. Output forward unpaired. So for the unpaired, you'll have a similar name here. Let me just copy this and paste. I'll copy up to this side and paste. And then I'll say dot trimmed dot unpaired underscore r1 dot fastq dot gz. That is for output forward unpaired. Now let's also specify the reverse reads. So reverse reads, I have output reverse paired. So that one too will indicate this one here. I'll indicate up to this one here. So I say equals, and then I'll paste it, and then I'll say underscore r2 dot fastq dot gz, because we are dealing with the reverse reads. Now we have output reverse unpaired equals, we bring the name here, trimmed, everything here, I'll copy and paste. I'll say dot unpaired underscore r2 dot fastq dot gz. All right, so you should make sure you also have something similar. So that's where a good naming convention comes in. So you will realize all the files have this base name here. All right, so we have the raw reads, and then with the process ones, I try to give some description here. So I have trimmed paired, trimmed unpaired. I also have r1. That means these are the forward reads. So with the forward reads, the files depend on the sequencing facility. We can have, for example, r1, r2, specifying or referring to forward and the reverse reads respectively. So that is what I am also using here. All right, and then for output reverse paired unpaired, we also have the names here. So we have trimmed, paired, trimmed unpaired, and we have R2, R2. So these will become our file names. All right, now let's indicate the number of threads. So I'll say threads equals 8. Now the number of threads, you can increase it. So depending on your computing power, you may have to increase this number or decrease it. If you're using a Linux cluster, an HPC system, you will have more threads or more cores, so you can increase this number so that the trimming process becomes faster. All right, so we are done with it. Now let's issue the Trimmomatic command itself. Now the Trimmomatic command, if you installed using conda or mamba or micromamba, then you have to use this Trimmomatic. You have to use it like this. But if you're using the jar file, like in my case, let's just do this. In my case, then I'll need to specify the path to the jar file. So that is what I'll do here. So for me, the path to the jar file is this one here. I'll just copy it. So it's going to be this slash, and then I bring the file itself. Okay, the jar file. So the directory first and then the jar file. Okay, this is how it's supposed to be, right? But because we have to also call Java, then this is how we are going to write it. So we will have to call Trimmomatic. So because we are using the jar file, okay, I have my Trimmomatic, I have my jar file here. I'll need to call Java first, and then I'll also supply Java with the jar file. So I'll say Java space dash jar, and then I'll specify my Java file. So the Java file can be found in what? The Trimmomatic directory. So I have to specify that directory. Let me just copy it. I paste it and I'll say slash, and then I'll specify the jar file, which is here. Like this. So this becomes the command for calling Trimmomatic. Now we need to specify the basic options. I made mention of that. So I have basic options, I have trimming options. All right, basic trimming. So we are starting with the basic options. So I will say P, and I'll say dash threads, and I'll say dollar threads. So that's the number of threads. Then I'll specify read 1, read 2. I have already defined them here. So I have them also here. I will indicate them here. Dollar read 1, dollar read 2. That becomes our input files. Now we need to also indicate the output files. So how do we do that? Let's look at it. So because the line here, if you try to supply too much information, it may be a bit complicated, or you have lots of information on one line. We will split them into separate lines. So here I'll bring a space and I'll say slash like this. So the slash here means that this line, the continuation is in the next line. That's what it basically means. Okay, so it's just a way to make things convenient for us. So I'll come here and I'll say dollar output forward paired dollar output forward unpaired, and then I'll also indicate the output reverse false. So I'll bring another and I'll say $output. Let's just put the correct spelling there, $output reverse ped. And then $output reverse unpaired. So we are done with the basic options. Now let's go to the next line, and that is where we indicate the trimming option. So the trimming options, we are using the options that were specified here. Everything here. So everything has been simplified. Let's just check here. Yeah, I think I've specified everything in this command here. I'll just do a copy and paste. This is the command. So I'll paste everything here. All right. So let's quickly go through the trimming options. Illumina clip is used to tell Trimmomatic that we want to trim Illumina adapters. And then the true-3-p.fa is the file that has the adapters. So here you have to specify the path to that file. This is ours. And then we also have 2. So the 2 here is for the seed mismatches. And then we also have palindrome clip threshold, that is 30, and we also have 10 that is used to specify the simple clip threshold, and we also have minimum adapter length, that is 8, and then we also have this option keep both reads, that is true. Then we also have head crop 3. So the head crop is used to specify number of bases to trim or remove from the start of the read. Then we also have trailing. So trailing here 10. Trailing is used to specify a threshold. So that means that at the end, or let's say the ending of the read, bases that fall below this threshold, the quality threshold here, they should be removed. That is what it means. And the main line here, this one here, it's used to tell Trimmomatic that reads that have their length below the threshold. Here is 25. So reads that have their length below 25 should be removed. So this is a quick description of, or let's say a brief description of the trimming options specified here. Again, just check the Trimmomatic manual. You have a description of each of these options, or you can also download the ebook that I showed earlier. Now let's exit and save changes. I will say Ctrl X. I type Y to save the changes. So that's about it. So if I do an ls, I'm going to find my bash scripts here. All right, so what we are going to do next is to add execution rights to the bash script, the one we created. So I will say chmod +X, and then I will specify the file. So now we have added execution rights. So after that, we will have to execute the bash script so that Trimmomatic will trim the read. So to execute, you can do this. You can say // then specify the file, or you can also say bash and specify the scripts. And so any of them should work fine, but I'll use the first approach. So I will say // and then I will call the scripts like this. So let's execute this command. Perfect. So once you do that, Trimmomatic will start running. Now there's something else I need you to look at. So with the quality encoding, we have this. It says quality encoding detected as Fred 33. So we can also specify the quality encoding scheme. We can use either Fred 33 or Fred 64. So it depends on your data. So here, because I did not specify, Trimmomatic automatically detected it for us. But if you know, let's say your data is Fred 64, then it's important to specify it explicitly. So if you don't know or you are not sure, you can leave it, and then Trimmomatic will do an auto detection and then get the quality encoding scheme. So that's what I thought I'll bring to your notice. All right, Trimmomatic has completed its work. So you also have a summary here to let you know what's happened. So with the summary, you have input read pairs, we have the number, we have both surviving, number and percentage, we have void only surviving, number and percentage, and we also have reverse only surviving, number and percentage, and finally we have dropped reads, we have the number and then the percentage. Now with this data, we got both surviving to be 100%, but it's not always that you have 100%. You can have less than 100%, and for the others, you can have more than 0%. So it depends on the data. So you can combine this information, the summary here, with quality control to decide if the trim reads are the ones you use for dashboard analysis or you use the raw reads. So just make sure to combine this with the quality control analysis results, and then you'll be fine. All right, so let's continue. Let's take a look at the output files. So let's do an ls. We are going to find the directory trimmed reads. So this has the output file. So we can say ls trimmed reads, and we will see our files there. So we have forward and the reverse, paired and then unpaired. All right, so that's what we have. So for dashboard analysis, you have to use the reads with made paired because we are dealing with paired and reads. So it's advisable to use the paired, the forward paired, and then the reverse paired. That's so that's what I recommend you use for the dashboard analysis, because if it's paired and reads, then obviously we should have the reads with their made pairs, and then that'll be it. Okay, so that's what we have. Now let's take a look at something else here. With the script that we use, let's just open it. The commands here are applicable for a single sample, but if you are dealing with multiple samples, then you need to modify this command to suit that purpose. So with multiple samples, you will need to factor in the sample names. You also have to factor in the type of read, that is paired end or single end, and you also have to factor in the file extension. These things are important. Okay, so if you have a situation where you have multiple samples and you want to use Trimmomatic to trim the reads, then you can contact me. My email address is in the description box. You can also check a video I made on that. So the link to that video is also in the description box. So just check all those stuffs and then let's see what happens. So that'll be all for this tutorial. And after trimming the reads, there are things that you can do depending on the data that you have. But one of the things that you can also do is to perform genome mapping. And I've covered a tutorial on that. Let me just say tutorial. So just check the description box and also just check the playlist that is being shown right now.